Hello da Tangam, welcome to GullyClassroom. This is the third lecture in the chapter Acids, Bases and Salts in CBSE 10th Standard Chemistry Science Book Chapter 2 Acids, Bases and Salts. This is the third lecture taken in English. We are going to continue the chemical properties of acids and bases. So what are we going to learn for the first reaction? We are going to learn about how do acids react with metal carbonates. We are going to learn about how do acids react with metal carbonates and metal bicarbonates. Okay, we have already studied in 9th standard itself about metal carbonates. Carbonates means CO3 2 minus. Carbonates means CO3 2 minus. Okay, what is called as bicarbonates? Bicarbonate is also a negative ion. It is simply HCO3 minus. How is this HCO3 minus, sir? Okay, let me tell you. Carbonate means CO3 2 minus. Hydrogen usually forms a 1 plus ion when both of them join together and form HCO3. 1 plus and 2 minus join together. 1 plus and 2 minus join together, which means you get 1 minus. This is called as bicarbonate, or HCO3 1 minus can also be called as HCO3 1 minus can also be called as hydrogen carbonate. It can also be called as hydrogen carbonate. Okay sir. Are you comfortable with this particular idea? Yeah. Can we go for the actual examples? Let us start the actual examples. The actual examples are, first let us take hydrochloric acid. I am going to put hydrochloric acid with calcium carbonate. Whenever I am putting an acid with the carbonate, this carbonate is released in the form of carbon dioxide. Okay sir, what next? Here there is hydrogen H and here there is oxygen. Whenever hydrogen and oxygen are present in the reactant side, you usually get a water out of it. What is the salt that is formed? Here there is chlorine and here there is calcium. We will get calcium chloride. How, sir? Calcium atomic number 20, 2, 8, 8, 2. So calcium will form 2 plus ion. What about chlorine? Atomic number 17, 2, 8, 7. So it will form minus 1. So let me bring the 2 over here. Let me bring the 1 over here. So I will get calcium chloride or CaCl2. What is the next reaction? I am going to take hydrogen chloride along with sodium carbonate Na2CO3. Once more, when an acid is added to a carbonate, I simply get CO2. Here there is a hydrogen and here there is an oxygen. Both of them combine and I get H2O. What kind of salt will this form? Here there is a chlorine, here there is a sodium. So I will get NaCl. What is the next example, sir? Let us take the same acid, hydrochloric acid, and put it with the NaHCO3. What is NaHCO3? NaHCO3 is simply sodium hydrogen carbonate. It is simply sodium hydrogen carbonate. When you are going to put an acid with sodium hydrogen carbonate, with a hydrogen carbonate also, carbon dioxide will be released. When an acid is put on carbonate and also when an acid is put on bicarbonate or hydrogen carbonate, you will get a CO2, carbon dioxide out of it. Here there is hydrogen and here there is oxygen. I will simply get H2O, and finally what salt will I form? I will form NaCl, sodium chloride. Okay, let us balance these reactions. Here there is 2 hydrogen. Let me put a 2 here. Here there is 2 chlorine. Yes, it is balanced. Here there is 2 hydrogen. Let me put a 2 here. Here there is 2 chlorine. Let me put a 2 here. Na. Here there is 2 sodium. So here also there is 2 sodium. The rest of the equation is balanced. The last equation is self-balanced. You can count the total number of molecules in both the reactant side and the product side. They will be same. The equation is self-balanced. Okay, sir. What are the things that I want to learn in this particular case? Here I am talking about here I am talking about calcium carbonate. Calcium carbonate has several names. What are the other names of calcium carbonate? Calcium carbonate's common names are chalk. Calcium carbonate is found in different types of physical forms. What are the different physical forms of calcium carbonate? Chalk, limestone. It can also be found as limestone. What next? It can also be found as eggshells. It can also be found as crushed eggshells. What is the next thing? You can also find it as marbles. You can also find it as marbles. So this particular first reaction is given by chalk, limestone, crushed eggshells. What type of eggshells? Crushed eggshells as well as marbles. So all of these are simply different forms of representation of calcium carbonate. Okay, sir. Okay, sir. What is the next thing that you want to teach here? Here all the reactions are giving carbon dioxide outside. This carbon dioxide needs to be detected. How are we going to detect carbon dioxide? Carbon dioxide will usually give a brisk effervescence. What it will give? Effervescence. VESCEN. Okay, let me write it once more. Brisk effervescence. Effervescence. Okay, so carbon dioxide will give brisk effervescence. What is brisk effervescence? When we are opening a soft drink bottle, small bubbles of carbon dioxide are coming from the bottom of the bottle to the surface. This is called as brisk effervescence. When we are opening a soft drink bottle, small bubbles of carbon dioxide are coming from the bottom of the bottle to the surface. This is called as brisk effervescence. So when we are having carbon dioxide in a reaction, there will always be brisk effervescence. What else? Carbon dioxide can be detected by 2 other methods. What are the 2 other methods? Carbon dioxide extinguishes fire. Carbon dioxide, what does it do? It extinguishes. Carbon dioxide, EXTINGUI, extinguishes fire. Extinguishes fire. So when you take a burning splinter nearby to carbon dioxide will simply put out the fire. What is another method of detecting carbon dioxide, sir? Let us take carbon dioxide and you are going to add carbon dioxide to CaOH twice. What is CaOH twice? CaOH twice is called as slaked lime. CaOH twice is called as slaked lime. What will happen here? In this particular reaction, you will get CaCO3 plus H2O. What is the nature of CaCO3? CaCO3 or calcium carbonate is simply a white precipitate. Just a couple of minutes before, we saw the different forms of CaCO3 or calcium carbonate. Calcium carbonate is a white precipitate. It does not dissolve in water. It simply collects around the bottom of the reaction vessel. It simply collects around the bottom of the reaction vessel. Hence the name PPT or precipitate. PRE, precipitate. Are you comfortable with this? Okay, sir. What next? So, carbon dioxide on reacting with slaked lime turns slaked lime milky. What is the meaning of the word milky? The formation of calcium carbonate, white precipitate, makes slaked lime into milky. You will look, there will be a milky look. The look of the slaked lime will become milky. So, carbon dioxide turns slaked lime milky by forming white precipitate, which is calcium carbonate. Okay, let us say you are going to pass an excess of carbon dioxide in this particular setup. So let us take excess carbon dioxide. And we will take this particular setup over here, CaCO3 plus H2O. What will happen, sir? Here the excess carbon dioxide will react with the calcium carbonate and form CaHCO3 twice, which is calcium bicarbonate. What is the name of this particular compound? Calcium. HCO3 means bicarbonate. What is the speciality of calcium bicarbonate? Calcium bicarbonate is soluble in water. So if you are passing carbon dioxide in slaked lime, you will get calcium carbonate. Lime water will become milky. Calcium carbonate is a white precipitate. It does not dissolve in water. But if you are going to pass excess carbon dioxide, what will happen? It will react and form calcium bicarbonate, which is in fact soluble in water. Are you able to understand this particular setup of how to detect carbon dioxide? Yeah? Okay, let us go for the next reaction. What is the next reaction, sir? We are going to learn about how do bases react with metals. For this, we are going to take the most common base. What is the most common base? NaOH or sodium hydroxide. What is the other name for sodium hydroxide? Sir, give me a second. Let me think. So the other name for sodium hydroxide is called as caustic soda. Caustic soda. So let us take a base. What is my base? NaOH or sodium hydroxide. Let us put it with zinc. It is a good example for an active metal. Now what will happen, sir? In this particular reaction, I will get sodium zincate, Na2ZnO2. This is called as sodium zincate. Yeah, and I will get hydrogen out of this. Hydrogen can be detected by the popping sound if you take a burning splinter to hydrogen. We have already seen this in the last lecture. Yeah, so base plus metal will give you a salt plus hydrogen. Sir, this is very similar to acid plus metal. What will, let us write a good example for this. Acid is let us write H2SO4, sulfuric acid, H2SO4 plus Zn. What will happen here? I will get ZnSO4, sodium sulfate, I will get zinc sulfate and hydrogen. I will get zinc sulfate and hydrogen. Both of these reactions are more or less one and the same. So the next thing you will ask me is, what is the difference when a base reacts with a metal and an acid reacts with a metal? Let me repeat myself. What is the difference when a base reacts with a metal and an acid reacts with a metal? When a base reacts with a metal, when an acid reacts with a metal, it always forms a salt and hydrogen. When an acid reacts with a metal, it always forms salt and hydrogen. But not all metals react with bases to form salts and hydrogen. Not all metals and bases combine with each other to form salt and hydrogen. Are you able to understand this particular idea? Okay, here they can ask you another question. What question, sir? You should never make vessels out of active metals. You should never make vessels out of active metals. For what, sir? For storing acids or bases. Acids and bases, what will they do? They will react with these active metals. Just as I have shown in the reaction, they will react with these active metals. These metals will form salts. And the vessels will get broken because the metals are reacting. The vessels will break and the acids or bases stored in these vessels that are made up of active metals. The acids or bases stored in vessels which are made up of these active metals will simply pour out. So you should never store acids or bases in vessels. What type of vessels? You should never store them in vessels that are made up of active metals. Are you able to understand this particular idea? Yeah? Okay, let me rub this off and go for the last reaction in this lecture. What is the last reaction in this lecture? We are going to see how do bases react with non-metallic oxides. We are going to look at non-metallic oxides. A good example for non-metallic oxide is CO2. What base are we going to consider here, sir? Let us take CaOH twice or slaked lime. If you put this, what will happen? Sir, this is a base. Okay. Non-metallic oxides are in fact acidic in nature. I have already studied this. Non-metallic oxides are in fact acidic in nature. So, how can I consider this? I can consider this as a base reacting with an acid. So, obviously, I will get H2O plus I will get a salt. What is the salt here? I will get CaCO3. Calcium carbonate is the salt here, which is a white precipitate. This bases plus non-metallic oxides can be understood as a good example for neutralization reaction. Is everybody able to understand this particular setup? Yeah? Okay, let me continue. That's basically the chemical properties of acids and bases. What is the next thing we are going to study? We are going to study about what will happen to acids and bases when they are mixed in water. The process of mixing water to an acid or base is called as dilution. So acid plus water, what will happen? Let us take hydrochloric acid. If you are going to put water here, this will break into H plus ion and Cl minus ion. H plus ion will never be alone. So it will combine with another water molecule and it will form H3O plus ion. What is the other name for H3O plus ion? It is called as hydronium ion. What will happen if base is added with water? For a base, when it is added with water, once more let me take caustic soda or sodium hydroxide and add water to it. What will I get? I will get Na plus and OH minus. Here, let us be very clear about this. Because H plus ion is formed when a substance is dissolved in water, it is called as an acid. Because OH minus or hydroxide ion is formed by a substance when it is dissolved in water, it is called as a base. Okay, now here this material is behaving as an acid because of the presence of H plus ions. Let me repeat myself. HCl is behaving as an acid. Why? Because of the presence of H plus ions, hydrogen ions, which are formed when you are dissolving HCl in water. NaOH is behaving as a base because of hydroxide ions, OH minus ions that are formed when NaOH is dissolved in water. So, if H plus ions are not formed, HCl will not behave as an acid. If OH minus ions are not formed, base NaOH will not behave as a base. With respect to this idea, let us look at the first question. Dihydrogen chloride gas does not turn blue. Dihydrogen chloride gas does not turn blue litmus to red. So BRA, all acids. A means it stands for all acids. Convert blue litmus to red. But an acid is an acid because it forms H plus ions when dissolved in water. If the acid is not dissolved in water, even though it is an acid, it will not behave as an acid. It will not behave as an acid. So, dry hydrogen chloride gas, because it does not form H plus ions, because it is not dissolved in water, it will not behave as an acid and it will not convert to blue litmus to red litmus. But what about dilute hydrochloric acid? Dilute hydrochloric acid means hydrochloric acid that has been mixed with water, because dilute hydrochloric acid already contains water, H plus ions will be formed and dilute hydrochloric acid will behave as an acid and convert blue litmus to red litmus. Are you comfortable with this particular question? Dry hydrogen chloride gas is not dissolved in water, so no hydrogen ion is formed. Because no hydrogen ion is formed, it will not behave as an acid, it will not convert blue litmus to red litmus. Whereas dilute hydrochloric acid, due to the presence of water, is broken into H plus ions, and these H plus ions will trigger the acid properties, and dilute hydrochloric acid will convert blue litmus to red litmus. Are you happy with this analogy? In the same way, with respect to bases, if you want to convert a red litmus to blue, then what you should do? You should dissolve a base in water. Once a base is dissolved in water, hydroxide ion will form. This hydroxide ion will give base its peculiar properties. Happy with this explanation? Let us go for the second question. Tap water conducts electricity, distilled water does not. Okay, so first look here. What is needed for the conduction of electricity? For conduction of electricity, you need one of two things. What is one of two things? You need either free electrons or you need free ions. Here, when an acid is dissolved in water, you get hydrogen ions which are free ions. When a base is dissolved in water, you get hydroxide ions which are indeed once more free ions. Because of the presence of hydrogen ions, acids in water conduct electricity. Because of the presence of hydroxide ions, bases in water conduct electricity. So, acids and bases in water have the capability to conduct electricity because of the presence of respective free ions. What are the free ions present in acid? H plus or hydrogen ions. What are the free ions present in a base? OH minus or hydroxide ions. Okay, let us get back to the question. Tap water conducts electricity. Why? Tap water contains small amount of acids and bases. How, sir? Most of the acids and bases we get from the minerals in the soil. Most of the acids and bases that we get from the minerals in the soil. Where does water flow? Water flows on the soil surface. It pulls some minerals. So, water that comes on the soil surface has some acids and bases in it. Hence, it has some H plus and OH minus ions in it. These ions help in the conduction of electricity in tap water. These ions help in the conduction of electricity in the tap water. What is distilled water, sir? Okay, let me rub this over here. Distilled water means, let me take a very large vessel here, fill it with water and heat it. Here, this water will get converted into vapor and come up. I am having a vessel here. Here, the water hits it and gets condensed. Once the water gets condensed, I can extract this. This particular water is called as distilled water. The speciality of distilled water is distilled water does not have any acids, bases or salts. Distilled water does not have any acids, bases or salts. Because distilled water does not have any acids, bases or salts, it has only H2O molecules. Automatically, it does not conduct electricity, because only when acids and bases are present, we have H plus and OH minus ions and they help in the conduction of electricity. Tap water conducts electricity due to the presence of acids and bases in it, which gives us some free ions. Distilled water does not conduct electricity because it does not have any free ions. Okay, sir. I am comfortable with the second question. What about the third question, sir? Write the name of the bases that are highly soluble in water. The name of the bases that are highly soluble in water are called as alkalis. What is an alkali? Bases that are dissolvable in water are called as alkalis. Sir, let me ask you a question. Are all bases dissolvable in water? No, not all bases are dissolvable in water. Let me repeat. Not all bases are dissolvable in water. Those bases that are dissolvable in water are called as alkalis. Alkalis are usually slippery in nature. A good example for alkali is NaOH, sodium hydroxide or caustic soda. A good example for alkali is NaOH, sodium hydroxide or caustic soda. Okay, sir. Let us go for the last one, fourth question. They are asking about dilution of an acid. What is dilution? Dilution is a process by which an acid is mixed with water. A dilution is a process by which an acid is mixed with the water. You can do dilution by two methods. What are the two methods? Let me take two vessels. In one particular vessel, I am going to take acid in the vessel. In another, I am simply going to take water. Here, I am going to have a setup like this. I am going to allow drop of. I am going to allow drops of water. Here, I am going to allow drops of acid. So, both of them simply represent two ways of simply doing dilution. What is dilution? Dilution is nothing but acid, addition of acid to water or addition of water to acid. Both can be called as dilution. But which is the best way to do dilution in the lab? In the lab, let's say you are having acid here. You are having acid in the vessel and you are allowing water to flow like this. Dilution is a highly exothermic reaction. Let me write it here. It is a highly exothermic reaction. It gives a lot of heat. So when water comes and hits the acid, a lot of heat is produced here. What is exothermic reaction? Look at my hands. X. Heat is going outside. My hands are going outside. So you will remember exothermic as heat is going outside. A reaction that gives heat outside is called as exothermic reaction. A reaction which gives heat outside is called as exothermic reaction. Okay, sir. What is endothermic reaction? A reaction which absorbs heat. Which absorbs heat is called as endothermic reaction. Does this look like a reaction which absorbs heat is called as endothermic reaction. A reaction which gives away heat, which gives out heat is called as exothermic reaction. Dilution is a highly exothermic reaction. It gives out a lot of heat. So here, when I am allowing water to come in drips, here a lot of heat is produced. This heat expands things, and this acid, due to expansion, might splash to the faces of the students, which makes this particular model very dangerous. So here, when you are adding water to acid, heat is produced. Dilution is an exothermic reaction. This heat expands the acid. This acid splashes to the faces of the students. So this is dangerous. This must not be done. This must not be done. Let us look at the second example. Here I am allowing the acid to come in drips into the water. Now what will happen? Let us say here a lot of heat is produced. Even if a lot of heat is produced, if here splashing is happening, only water will be splashed and the students will not be disturbed. Only water will be splashed and the students will not be disturbed. So usually for dilution of an acid, what are you going to do? You are going to add acid to water and not water to acid. You will add acid to water and not water to acid. Are you comfortable with these 4 repeated board questions? Give reason questions. Yeah, I totally understand this could be a slightly long lecture, but I sincerely hope I did not bore you guys. I had so much fun taking classes to you. If you like and love our lectures, basically that's the end of this particular lecture. If you like and love our lectures, hit the like button, hit the bell icon, subscribe to us, recommend our channel to your friends. Let us have fun learning chemistry together. Cheers and thanks, Tanga. Cheers and thanks. Bye da.